You ever see the news and wonder how they can call a whole election just by asking a couple thousand people? Or, how a company figures out a new phone is going to be a hit from just one tiny focus group? It sounds kind of like magic, right? Well, it's not. It's actually one of the most powerful ideas in all of statistics. And today, we're going to pull back the curtain on how it all works. I mean, this is the big question, isn't it? It just feels wrong. How can such a tiny slice of the pie possibly tell you what the whole thing tastes like? If you ask one group of 1,000 people, you're going to get one answer. Ask a different group, you'll probably get a different answer. It feels like it should be totally random, but we rely on it for everything. And here's the cool part. The answer isn't a trick. It's a logical, repeatable process that's all grounded in math. And I promise, by the time we're done here, you'll get exactly why one small, well-chosen clue can let us see the bigger picture with, honestly, some pretty shocking accuracy. Okay, so to make this feel real, we're going to dive into a case study. Let's forget about millions of voters for a minute and zoom in on a company called EAI. They've got 2,500 managers, and our mission, should we choose to accept it, is to figure out their average salary. The catch? We can't ask all 2,500 of them. We need a shortcut. So first things first, let's get our words straight. The population, that's everybody we're interested in. In our case, it's all 2,500 EAI managers. That's the whole truth. The sample, that's just a small piece of that group, the ones we actually talk to. Think of it like a detective finding one single clue that points towards the real story. Now, just for us, just so we can see how this works, I'm going to let you in on a secret. We actually know the real answer. The true average salary for all 2,500 managers is exactly $51,800. So that's our target. That's the bullseye we're aiming for. The real question is, can one small sample even get us close? All right, let's give it a shot. We're going to do what's called a simple random sample. All that means is every single manager has the exact same chance of being picked. So we grab 30 of them at random, we crunch the numbers, and look at that. Our estimate is $51,814. Wow, that is ridiculously close to the true answer of $51,800. So it works, right? Case closed. Or is it really that easy? And here's where the plot thickens. That was just one sample. What if we had picked a different random group of 30? You think we'd get the exact same answer? Let's see what happens when we try it again. So we do it again. Our second sample gives us an average of $52,670. Okay, different. We do it a third time. We get $51,780. A fourth time, $51,586. This right here, this is the big problem. Every sample you take gives you a slightly different answer. It's something called sampling variability. Each clue seems to point in a slightly different direction. Which, leads us to this massive question. In the real world, you only get to take one sample. So if we know that every single sample is going to be a little bit different, how on earth can we trust the one answer we get? It kind of feels like we're right back where we started with a method that seems totally unreliable. But here is. This is the big breakthrough. The secret isn't to look at one sample by itself. The magic happens when you look at the pattern created by tons of samples. So let's go nuts. Instead of just 4 samples, what if we took 500 different random samples of 30 managers, and we plotted all 500 of those results on one chart? And there it is. That's the aha moment. When you plot all 500 of those sample averages, the chaos just vanishes. A beautiful, clear, bell-shaped pattern emerges from the noise. And look at it. The vast majority of our estimates are huddled right around the true answer of $51,800. Sure, you could get a sample way out on the edges, but it's super rare. The randomness isn't so random after all. It creates a predictable shape. This amazing pattern has a name. We call it the sampling distribution. And it's a bit of a weird idea. It's not a distribution of people, it's a distribution of statistics. In this case, it's the pattern of all the possible sample averages we could have gotten. And understanding this pattern, well, that's the absolute key to everything. So, why? Why does this happen? Why do all these random little samples line up into such a perfect bell curve? It's not a fluke. It's because of one of the most important ideas in all of statistics. It's kind of the hero of our story today. Meet our hero, the central limit theorem. This is the statistical superpower that makes sampling work. It basically says, as long as your sample is big enough,
the sampling distribution of the average is going to look like that normal bell-shaped curve. But here's the part that will blow your mind. This is true even if the original population of salaries wasn't bell-shaped at all.
Yeah, I know it sounds wild, but look, here's the proof. On this slide, we've got 3 totally different populations. One is flat, one is M-shaped, and one is all skewed to one side. None of them look like a bell curve. But look what happens to their sampling distributions when we take samples of 30. All 3 of them. Bam! They transform into that perfect, predictable bell shape. That is the magic of the central limit theorem right there. Okay, so we found a predictable pattern. So what? How does that help us, since in the real world, we only get our one little sample? Well, the power of knowing this pattern exists is that it allows us to control how confident we can be in our one single guess. And this slide shows you exactly how. It's comparing 2 different sampling distributions. The one on the left, the wider, flatter one, that's the one we've been seeing from our samples of 30 managers. But look at the one on the right. That's what the pattern looks like if we use a bigger sample size, say 100 managers. See how it's taller and skinnier? It's way more tightly packed around the true answer. And that is the crucial takeaway. Making your sample size bigger doesn't change where the middle of the curve is. It's always going to be centered on the truth. What it does is it shrinks the spread. It tightens everything up. A larger sample reduces that random wobble from sample to sample, and that means any single sample you happen to take is much, much more likely to be extremely close to the real answer. This is how we buy confidence. And really, that brings us to the whole point of all this. We know we're never going to be 100% sure that our one sample gives us the perfect answer down to the penny. But because of the central limit theorem, we understand the predictable pattern of how wrong we might be. This is how a pollster can say they're 95% confident about something. So you see, the goal of sampling isn't about being perfectly right with a single guess. It's about being precisely confident in just how right that guess is likely to be.